Hello and welcome to another math video. Today we're going to be focusing on working with some linear equations and inequalities. We start with question 1. We're going to find an equation in slope-intercept form of the line that satisfies these conditions. So we're looking at a slope of 3 and it goes through the point 7, negative 6. Now they do want the equation in point slope form, but if we start with our slope-intercept form, they want slope-intercept, we're going to start with point slope. We can plug in all of our information, and then it's just a little bit of algebraic manipulation in order to get this to slope-intercept form. So we would start by distributing that 3 through to the x minus 7, so we get 3x minus 21, and from there we just subtract the 6 from both sides. So when we do that, we end up with 3x minus 27. So there's the equation in slope-intercept that they were looking for. The second question, same sort of thing. They want the equation in slope-intercept form. In this case, they give us 2 points to work with. So very first thing we need to do is calculate the slope. So we start, again, remember we always put the y-coordinates on top. So if I go 7 minus 3, starting with the 7 means I have to start with the negative 3. And then it's minus the negative 6, so again, if you want to change that to plus 6, that works. So we get the 7 minus 3 there, we get 4, and then negative 3 plus 6 would be 3. So slope of 4/3. I think I'm going to go with the point negative 6, 3 when I write my point slope form. So that would be y minus 3 equals 4/3 x plus 6. So we need to, again, start by distributing the 4/3. Y minus 3 equals 4/3 x plus, that would be 24/3, which would turn out to be 8. And then we just add the 3 to both sides, and we end up with y equals 4/3 x. Adding 3 to the 8 gives us 11. So there's the slope-intercept form of the line that goes through those 2 points. Next we're looking at, again they tell us that they want it to go through negative 6, 5, and they want it to be parallel to negative 7x plus 5y equals 57. So again, given that standard form, there is a trick for finding the slope there. If the slope is the opposite of a over b for that standard form, so the opposite of a negative 7, so that would be a 7 over 5. So the slope of 7/5 is the slope for that line, and of course any line parallel to that would also have a slope of 7/5. And then, so basically that was just a fancy way to give us the slope and a point. So if I go back to my point slope form, we would have y minus 5 equals 7/5, and then that would be x plus 6. Now the fractions here are going to be something that we need to deal with, so we will distribute that 7/5 through. So we get y minus 5 equals 7/5 x plus, and then we do this 6 times 7, which of course is 42, and we get 42/5. We would add the 5 to both sides of that equation, so we get y equals 7/5 x. 5 would be 25/5. Adding 25/5 to 42/5 gives 67/5. Now you could leave it as a fraction. I actually don't mind fifths as decimals because they're all nice terminating decimals, so certainly could use that as well. Moving on to number 4. Now the difference here between 3 and 4 is that we're told we want it to be perpendicular. I can still use the same trick to determine the slope from the standard form here. So this slope would be 3 over 4. So the perpendicular slope to that would be negative 4/3. So that's the slope that our line has. And so again, just a fancy way of giving us a slope of negative 4/3 and through the point negative 3, 8. So again, if I start with my point slope form, y minus 8 equals negative 4/3 and then x plus 3. At least the fractions won't be bad this time when we multiply the negative 4/3 through. So we get negative 4/3 x minus 4. And then we just have to add the 8 to both sides. When we do that, we get y equals negative 4/3 x plus 4. And that's the equation that we're looking for that's perpendicular to the equation they gave us and goes through that point, negative 3/8. Then starting with number 5, where we start our work with linear inequalities. So we have to graph the boundary line and then determine which side to shade. Now in this case, just a little note for myself, this will be a solid boundary line for this one. Now a lot of times I'll just use the standard form to grab the slope and the y-intercept. However, this one, since it already has just a plain old y, it is very easy to subtract the 3x from both sides and get the slope-intercept form. So I can see that the y-intercept is negative 3, which again would also be 0, negative 3 if you want to write the whole ordered pair. And the slope is also negative 3. So I can start by graphing that y-intercept. And again, I'll do my best on here. Sometimes the graphing can be a little difficult. And then from there going down 3, right 1. And I'll do that a few times so I have a good idea, and then I can switch and go up 3, left 1, and again do that a few times so I cover the graph well. Again, then we do a solid line through those points, and I just like to change colors so the points stay clear there. Now, so that gives us the boundary line. Now we need to determine which side to shade. There are a few different methods you can use there. One popular one is plugging in a test point like the origin. Safest to do that in the original. If you plug 0 into the original, and again the nice thing about using the origin there is that it just simplifies very nicely for what we're doing, because you plug a 0 in for x, a 0 in for y, you end up with just 0 on the left side. And so testing that origin gives you 0 is less than or equal to negative 3. Well, that's false. So that test point being false would mean we would shade the other side of that inequality. The trick I like to use is if the y, so it's a positive y, it's less than something, that tells me that it goes down the y-axis. You can do the same thing with the x. The 3x, it's a positive x, it's less than something, so that goes to the left on the x-axis. So all those things are agreeing we shade that kind of down left side. Because of how the video works, I'm not going to bother coloring that in, but again you can see that that's the side where that gets shaded. For number 6, we have a compound inequality that we're working with. Notice it's a compound inequality with and, so we only graph where the two overlap. I'm going to start with the x minus 1 is greater than 0. If we add the 1, we get x is greater than 1. From that, again, we know that will be a dashed line at 1, so I'll do my best here to dash a line. Again, dashing doesn't work the best on here either. That's my dashed line for x is greater than 1. Again, that would end up being shaded on this side. And not knowing where that other line will intersect it at, I will go ahead and kind of draw a couple arrows showing that it's shaded that way. Again, I could use the standard form just to pull the slope and intercept out of here, but this one with just the plain y, so easy to subtract the 2x from both sides to see then that the y-intercept is 4. And the slope is negative 2. So if I plot those, y-intercept of 4, slope of negative 2, and I can continue doing that for a ways. And so it looks like that. Now this one is solid. Again, if I switch color so that the points stay clear. Again, I could use a test point. I'm going to talk first though about the other method that I like to use. Again, so both the x and the y are on the small side of the inequality. So, and they're both positive. So that would show to me then that it goes down or to the left on the x-axis and down the y-axis. So I'm just going to go down from there. So we can see which side we get shaded there. And then, again, since it's and, I will be a little bit more clear here. Since it is and, we would shade this area here, would be the area that gets shaded in. That's where they both overlap, and so that's the part that gets shaded. Again, since it's and, that's the only part that gets shaded. We don't shade over here because this is only shaded for the x is greater than 1. We don't shade over here because this is only shaded for the 2x plus y is less than or equal to 4. And then we don't shade up here at all because that's not shaded by anything. For number 7, we have a compound inequality that uses OR. So again, here we'll shade anything that's covered by either one. And I'll start with the x is greater than 2. Again, that's another dashed line. So again, I'll do my best to dash a line here. Looks like that. And then greater than the 2 would be this side here. The 3x plus 2y greater than 4, again, you could still solve this for y to get it into slope-intercept form, but again, just to talk again about pulling that information out of the standard form. So standard form, the slope is the opposite of a, so negative 3, over b, which is 2. So slope of negative 3 halves. The y-intercept ends up being the c value, which is 4, divided by b, which is 2. So 4 divided by 2 giving us 2 there. So the y-intercept of 2 and the slope of negative 3 halves, so down 3, right 2, looks like they intersect right there. I would want to continue that pattern a couple more times at least. Gets to be a little tough without an actual grid here. And also going up 3, left 2, and a couple times there as well. So again, that line is also dashed. So that would look like this. And again, using that same method I used before, x and y are both on the greater than side of the inequality. So the y values are greater as you go up, either the y-axis or however else you want to think of it. The x values are greater as you go to the right. So we're looking at those areas there. And so we shade wherever both of those overlap. So in this case, everything on this side of this line and everything on this side of this line. And so we can fill in those areas completely, really. So all of that gets shaded. So this area over here is the one area that is not shaded for either of those two inequalities. And then for our last question, we come back to just graphing a single linear inequality. Now this one, one of the tough things here is that we don't have a nice y-intercept. So if I pull that information out using the standard form, it's a negative 1 over a positive 3 for the slope. The y-intercept would be 2/3. Now we could work with 2/3, but the x-intercept works out to be a nice point of 2, 0. So I would rather work from there, so point at 2, 0. Then if we go down 1, right 3, we get to some other points that we can use as well. And I can go up 1, left 3 also to get to a few other points. And then just continuing that pattern to fill that in. This one is a solid line, so it would look like this. Again, I could use the origin to test if I look at using, again, the trick that I like to use. X and Y are both on the big side of the inequality, so that would be going up for Y, going to the right for X. They agree that it's on that side. If we tested the origin we plug the zeros in there, that would turn out to be false. It would say 0 is greater than or equal to 2, which of course is false. So we shade this side up here. So everything up here gets shaded for this inequality. Well, hopefully you found this helpful, and as always, thanks for watching.